Today we're going to be looking at the arc length within circles. Tomorrow we're going to look at sector area, or the next video, depends on if you watch it today or tomorrow, I guess. First, some basics about circles. We're going to be looking at central angles. A central angle is an angle formed by two radii of a circle. So the vertex of it is at the center of the circle, basically. A couple of radii are forming it, and that is a central angle. The arc measure is a measurement in degrees of an arc. And it is equal to the central angle. So like in this circle here, this central angle here is 55 degrees. So the arc going with it, which is arc CD, is also 55 degrees. This is called a minor arc. It is when an arc is less than half of a circle. A major arc is when an arc is more than half of a circle. Like if I went all the way from E all the way around to this point D. To name a major arc, you would need 3 letters like E, B, D. To name a minor arc, you only use 2, like DC. And when they name an arc, they put a little curve symbol over the top of it. In this image, I'm going to go ahead and find all of these central angles just to kind of practice a problem doing that. Notice these congruent markings here. You also still have vertical angles that are applying. So like AD and EC are creating a pair of vertical angles, and so this would also be 55 degrees over here. And in order to use those congruent markings to help us, if we went all the way from A to D, this is a diameter, the AD here, and that means that all the way around that would be 180 degrees. So if we take 180 degrees and subtract 55 and divide that by 2, we'll get each of these angles, which are going to be 62.5 degrees each. This one over here can be found doing 180 minus 55, giving you 125 for that central angle. And then each of the arcs will be equal to those inner angles as far as degree measures. Circumference is going to be used. Circumference formula, 2 pi r or pi d. For this circle here where the radius is 4, you would do 2 pi times 4, giving you 8 pi inches for the circumference, or approximately 25.1 inches if you got that as a decimal value. For area, pi r squared. So pi times 4 squared, that'd be 16 pi inches squared, and 16 pi as a decimal would be 50.3 inches squared. So either of those answers is good for that. An arc length is the distance length of an arc. It's measured in inches or feet or something like that. So you're going to need to watch for, are they asking for arc length or arc measure? The arc measure is in degrees, and the arc length will be in whatever unit measure the radius is in. Like this one is in meters, so the arc length will be in meters. You can either do the arc length as doing a fraction of the circumference, or you can use a proportion, which is what I like to use. The proportion is the arc length over the circumference equals the arc measure over 360. It's over 360 because that's the degrees in a whole circle, and it's over 2 pi r because that is the entire length all the way around the circle. So if you think of this as like part over whole equals part over whole, that's what I do when I'm working these problems. So to find the arc length of arc AB, which is just from here to here across the edge of the circle, What I do is I take my angle, which is 88, I divide that by 360 because that's a full circle. And then I am finding the part of the circumference, so I need to put that over the whole circumference. The whole circumference is 2 pi r, and the radius is 2, so 2 pi times 2 is 4 pi there. And now we've got it set up, and we're just going to cross multiply and solve for x. So when you do 4 pi times 88, you get 1,105.8, and then 360x, and then we're going to divide by 360, and that gives us 3.07 meters for x. Now, if you wanted to keep it in terms of pi, you would do 88 times 4 divided by 360 and do like math enter if you had a graphing calculator, and that would give you 44 over 45 pi meters. But I think this one's probably going to be asking you just to round to a certain decimal value. Here are a few more examples. It says if VS is 12 meters, well, that would be the diameter. Find the length of arc UT. So UT, this minor arc here from U to T. So again, we're going to be setting up our proportion over 360 here, over circumference here. Circumference pi d is going to be 12 pi. And then we are finding the arc length, and we're going to have the angle measure in a moment. So if this is 90 and this is 127, well, you can see that like vertical angles here, that this whole thing would be 127. And so 127 minus 90 is going to leave you with 37 degrees for this piece that we want to get. So 37 is the arc measure in degrees. And we're going to cross multiply. So 37 times 12 pi, 444 pi, 360 times x. We're going to divide by 360, and that will give you either, if you want a fraction, 37 over 30 pi meters, or if you go ahead and go decimal form, about 3.9 meters. Here we want to find the circumference. Remember that the formula, the circumference, is the bottom right part. So that is what we're going to find. The whole circle and the whole circumference. They gave us the piece of the arc length as 46.75, and they gave us the degrees as 290. So we're going to cross multiply here, giving us 290 times c, and then 360 times 46.75 gives us 16,830. We're going to divide by 290, giving us circumference of 58.03 feet. For our last one for today, we're going to find the radius. So in the formula, think about where the radius is. The radius is a piece of the circumference. That's this 2 pi r. So I'm going to put 2 pi r here. We're solving for r. 360 always goes there, our angle for the piece, and then we have the piece of the arc. We're going to cross multiply, which is going to give us 110 pi r, 7,095.6. We're going to divide by 110 r, or 110 pi, sorry. And as you're doing this, be sure that you put this in parentheses or use a fraction template. You've got to make sure that you're dividing by the product of 110 and pi. If you are not careful, you'll end up dividing by 110 and then multiplying by pi. So use caution as you do that step. Should be getting 20.53 centimeters for the radius. And that's how you do arc length. So it's just using this proportion to solve for the piece that's missing.